A dream job,
I believe it.
dream
Yeah.
job. And, I worked 13 missions while I was down there, STS 26, return to flight, all the way, yes, I think it was STS 42. Each mission was different, each was challenging. What they would do is you would have a flight control team. So for every person you see in the front room in the big where there's a flight director and all those rows of green cabinets with the monitors on them and the big screen in front, there's there's two or three people, maybe more, in a back room for each one of those positions. So you start out, you're in the back room, right? You learn the skills. They break down a very complex system. The space shuttle had 3 or 4 times redundancy in many systems, and so you're looking at all the switches, the valves. I was in a system called OMS RCS, orbital maneuvering system and reaction control system. And so, you had to worry about how much fuel was, how much oxidizer, how much fuel, where the valves were. We connected into a system called GNC. What happens though is that for 1, 2, 3 years, there's a flight control team and there's the astronauts that are associated with. There's a team of trainers for the flight controllers and a team of trainers for the astronauts. And so you become a team, much like in the Marine Corps, much like on a hockey team, even at a higher level. So you see these people every day and you're reading the rules, you're reading the system. You have what's called bingo numbers. You have a priority list of tasks that have to get done. So I've never experienced anything like that in my life, but I've yet tried to carry that experience to wherever I went, because, I guess a lot of people understand the football analogy, right? There's a quarterback. The quarterback does certain things, but a lineman do different things. Is a quarterback more important than a lineman? Goodness, no, right? I mean, they might have a different skill set. It might be much more visible. But if you watch a football game today, and there's what's happening on the line on both the offensive and defensive side of the line is as interesting and dynamic and exciting as what you're seeing the quarterback and the receivers and running backs are doing. Anyways, going back to the analogy, I'm sorry, I'm rambling, but you have that team structure and everyone knows what they're going to do, and I found, and I can't claim this for everybody, but personalities kind of get put to the side when you have people's lives on your line, right? They're in space. The ascent phase is very challenging, as we understand. It's very dangerous. Re-entry is very dangerous. Orbital, they break the mission up in those 3 phases: ascent, entry, and then there's, or I guess you call it 2 phases, but there's the ascent entry team, then the orbital phase. They all present different challenges, and it's all around mission success. And what do you define success as? What would you think? What's success for
Getting home.
get them home alive?
Yep.
Yeah, get them home alive. Yeah.
And I'm curious, as you're getting started and getting into that team, it sounds like everyone had very clear definition of what their role was and what their job function was, and everyone knew, what each other, needed to do to ensure that success happened. Was that just really good training? Was that just getting the right people? Was that a combination? Like, how do you think that it was set up in such a structure that everyone was able to function at that such high level in those situations?
Well, I mean, so, there's a whole interview process when you get there, and that you start training, quite honestly, by reading a book, right? So you'll have a system, and there'll be diagrams in those systems. There's valves, there's electronics, there's if your system has memory, or if it has a power unit associated with it, and you had to memorize that system, and there was the nomenclature that went with it, and everything, and you had to sign off on it, and then you would take a test and a quiz, and then you would participate in simulations where there were just flight controllers in the simulator. In the simulation room, the astronauts might not even be, the astronauts may or may not be in a fixed base system, or they might be in a motion based system. But the point is the trainers, the simulation people, they would throw problems at you,
Okay.
right? And they would record everything. And afterwards, you would have a debrief, and they'd say, "This is what you did wrong. This is what you did wrong. This is what you did wrong." And you found out, through the training, the dedication to learn the systems, to learn the nomenclature. You're wearing a headset there, and you're listening to 3, 4 conversations at a time, and you're tracking numbers on the screen. Pressures may be dropping, fuel levels may be dropping. What does that mean? Is it temperature related? Is there a leaking jet, et cetera? And then you've got rules that go with that. And these rules, just like the rules we have today, in society. They evolved based on mistakes that happened. Why do we have a four-way stop sign? Because people are driving through it and they're hitting each other, right? No one's yielding to each other. So we had to put a four-way stop sign in. Oh, well, why do we have speed limits? Well, speed limits because you're near a school and you shouldn't be doing 55 in front of a school, right? So the same thing and when you build, this whole idea of building mission flight rules is based on the same thing. So if you have these two jets go down on a yawing axis, what's your backup plan, right? So that's why you have quad and triple redundancy on a number of these on a number of components of the system of the space shuttle. Anyways, was there selection and training process? Yeah, you knew who was good and who wasn't. So you would start in the case of our system, there were two backroom positions. Um, One had to do more with the fuel and the oxidizer. The other one had to do with the system configuration of the valves and the switches and the jets. Um, and then, you would get certified in each one. So you get certified in the propulsion side for an orbital mission. Then you would get the second seat, and then you would swap and you get certified in those. And then if you got good enough, then you would move to the front room. You might do an orbital mission in the front room, right? And just like anything else, there's 3 shifts. The astronauts are in orbit the whole time. So, there's an opportunity for you to work on that. And then you ultimately end up into the ascent entry phases, which are very dynamic. So I
And
don't know.
about how much, like, on average, how much time would it take someone to get through all those certifications and go through that process to get the chance to be involved on the final phase?
Well, it depended on the individual, right? And I don't recall exactly. I mean, I worked in the back room on STS 26. I think I was there maybe 6 months.
Okay.
On the orbital side of the mission. It was a very benign mission. The goal of that mission, primary goal of that mission, is just to return to flight. I don't even remember what the payload was, but the launch, just watching the launch and participating in the mission, the fact we were back in business was that was the whole focus.
Mm.
Yeah, that was we demonstrate our capabilities. Mhm.
And how long did you hold that position, and how long were you? I mean, you mentioned the amount of different missions that you did, but how long a period of time was that?
Well, I was at NASA for 5 years,
Okay.
and like I said, 13 missions, and I don't remember all of them. I have to go back and look at my notes, how long
Yeah.
it took me to get to every different position, because also it decided on was, you know, was somebody else leaving that position and they're going on their career in different roles. So just because, as a flight controller, you can go in a lot of different directions. You could go work on advanced orbital systems. You could be an administrator of NASA at different levels. So there were people, and then, as a contractor with Rockwell, we had different roles as well, where our roles were more just staying on the council and becoming proficient expert flight controllers in your discipline. So, but I don't. I'd have to go back and look at my notes. I don't know.
Yeah, no, that's fine. And I'm curious, at this phase of life too, are you starting a family at that phase? Are you married? Anything? And you mentioned you moved to Chicago with, or because you met someone at that phase, or tell me a little bit about that side of your story.
That was um, love is what love is.
Yeah.
The heart loves what the heart
Yeah.
loves. But that was a great time in my life. It was, I'd never lived in a big city
Yeah.
before. That was quite exciting, and made some great friends there. I'm still very close with a friend there, Berta, and her family, and I had some other great relationships up there. But I was single when I was down at
Okay.
NASA.
Yeah. And then, so you went through NASA. You mentioned you've been there for 5 years, and you're now onto what's next, right? And what was that?
Geez, what a great story. So I was down there, and there's these guys, and one of them's name is Peter Diamandis. I can't remember all the other ones, but they started a program called the International Space University.
Hmm.
And at this point in the 90s, the wall came down, right? It's obviously the wall came down, and there was more of this, international collaboration.
Yeah.
And so this group of gentlemen started the International Space University, and it started out summer programs. And I applied to go to the International Space University, and they went, I was in the second class. It was in Toronto in 1990, another 10-week program. And I said, this is for me, because they would study space physics, space humanities, space law. So you had a 10-week program, and they immerse you in all these different space-related topics.